All right, how are you going to identify security misconfiguration? What does a denial of service attack actually mean? And how do you prevent a denial of service attack against your API? And of course, how do you ensure proper logging and monitoring? This does sound kind of boring, but it's actually super important. And these are the things that we're going to be talking about in today's video, which is the part 2 of the OWASP API security sections. And yeah, let's dive into it. This is a really fun room, and we're going to wrap this up and we're going to go on with the rest of our software security modules. All right, as a part 2 to our API security for OWASP, we're just going to jump real quick just for the recap of it. So in the last video, we did the first 5 principles. Now we're going to do the next 5 principles for API security, or the remaining principles. I think it's only 3 actually. So identifying security misconfigurations, preventing denial of service, and ensuring appropriate logging and monitoring. Same prerequisites do apply for this particular room, and the rest of it is pretty simple as far as just getting started with this thing goes. So let's look at the 6th vulnerability here, which is the mass assignment vulnerability. All right, this one's actually not easy for me to grasp. So I'm actually going to read through this because I read through it already and I just want to reread it just to make sure that I understand it. So mass assignment reflects a scenario where the client-side data is automatically bound with server-side objects or class variables. So client-side data meaning coming from us through our web client or our computer, and it's automatically bound with the server-side objects or class variables. So hackers exploit the feature by first understanding the application's business logic and sending specially crafted data to the server, acquiring administrative access, or inserting tampered data. So they first understand how the logic of the application works, then they send specially crafted data to the server that will allow them to acquire either privileges or insert tampered data, like poisoning or inserting malicious data. This is widely exploited in the latest frameworks like Laravel, Code Igniter, etc. And consider a user's profile dashboard where they can update their profile, like their email, name, address, and the username of the user is a read-only attribute and can't be changed. However, a malicious actor can edit the username and submit the form. If necessary filtration is not enabled on the server side, on the model side, it will simply insert and update the data in the database. And so what they can do is they can tamper the data or escalate privileges from a regular user to an admin by doing this. And we're actually going to check out the API website that we used in the last video as well to make some requests here. And so the rule is rule number 6. It's a user, and rule number 6 / user is basically the endpoint, and we're going to be sending post requests. And with the post request, we are going to send, what are we sending here? The table has a credit column with a default value of 50. Users will upgrade their membership to have larger credit value. And Bob has successfully designed the form and used the mass assignment feature in Laravel to store all the incoming data from the client side to the database as shown below. So this is the information that could be sent through the post request. And so the content type itself is the application X form. It's like a form, obviously. There's the name, username, and password, and then the credit parameter that comes default by 50. But then I guess if you know how to manipulate this, then you can give yourself as many credits as you want. And then the response itself will say that it's been created, and it gives you a successful response, including the number of credits that you have in the situation. There's no filtering that's happening on the server side, and the mass assignment feature, it's also inserting credit values in the database, which the hackers and attackers can update for themselves or manipulate that data. So the solution is so that we need to ensure filtering on the server side, which will just be on the endpoint user S for secure, and ensure that the default value of the credit should be inserted as 50, even if more than 50 is received from the client side shown as below. So same thing, there's the updating the same or sending the same type of information, but then once it creates the user, it just keeps their credit value at 50 instead of updating it to 110. So the mitigation for this type of vulnerability is, before using any kind of a framework, we need to understand the backend insertions and updates and how they're carried out. And in Laravel, fillable and guarded arrays are what are used, and so you can mitigate the above scenario by using those types of arrays. And so avoid using functions that bind an input from a client to code variables automatically, and allow list those properties only that need to get updated from the client side. And it's a good practice to is it good practice to blindly insert and update user provided data in the database? That would be no. And using our secure API, insert a record in the database using the credit value as 1,000, and I already marked it correct because it didn't require any kind of an answer. So what would be the return credit value for performing question 2? I'm just going to guess 50, yeah, because that's what the content said. But we'll actually do that exercise just so we can see kind of what it looks like when you do use the secure endpoint. So I'm going to open this up and we're going to go into full screen mode just to make it a little bit easier. And it should already load our API emulator for us. And so we're going to API rule 6, user secure. So here we go. Okay, and we're going to make a post request, and this is the content type, and so we're going to create a new, what are the users that we're going to, so name, username, password, and credit. So we'll do name, username, password, and credit, and we'll do sending 1,000. So let's send that. I already created it for us, and our credit was actually 50 instead of 1,000. So that is a secure API endpoint. So very good. Let's move on to the next one, which is going to be the security misconfiguration vulnerability number 7. All right, security misconfiguration basically means incorrect and poorly configured security controls that were placed and implemented, and so it put the entire API at risk. It put the entire security of the API at risk. And a lot of things can end up to this particular vulnerability, including improper or incomplete configurations for your default configurations, and then publicly accessible cloud storage, which is not good. So you don't want publicly accessible cloud storage. It needs to at least be some kind of a hybrid or some kind of a private cloud storage. And then cross-origin resource sharing, which I actually don't know what it is. So let's see what this is. Cross-origin resource sharing is an HTTP header based on the mechanism that allows a server to indicate any origins, which would be the domain or the scheme or the port, other than its own, from which a browser should permit loading resources. So CORS also relies on a mechanism by which browsers make a pre-flight request to the server hosting the cross-origin resource in order to check that the server will permit the actual request. In that pre-flight, the browser sends headers that indicate the HTTP method and headers that will be used in the actual request. The example would be a front-end JavaScript code served from domain whatever using the fetch method to make a request for the data JSON, and browsers restrict cross-origin HTTP requests initiated from scripts. For example, fetch and XML HTTP request follow the same origin policy. This means that a web application using those APIs can only request resources from the same origin that the application was loaded, unless the response from the other origin includes the right CORS headers. So you send a get header to the web server, get layout, you send a get request for the main page, which is what the / is. So you send a get request to the main page of the web server, and then you send a get request for the layout custom style sheet of the web server, and then you get an image from the web server. And the main one, the very basic one, it defines the origin that it needs to be used, and then when you do the get image PNG, should have the same origin request. So it should be coming from this same origin, which is always allowed. Now, if you get the image PNG from a different origin, cross-origin request, which is controlled by a course, it is not allowed. So that's what this means. So if you have your first request, which is the main page, the original domain name, domaina.com, for example, and everything else that you do on this particular website should be making that same request from that same domain / whatever the other data is, other endpoints or other resources are. And if the request that you're trying to make, so it could be image.png or any name, any file, essentially, you could be using that same file name, but if the base domain itself, the main domain, is not correct, then the cross origin, the course, would be set off and it wouldn't allow you to do it. Sorry for the noise in the background. I have certain people that just roll through my block, and it's so funny. We have like a really basic neighborhood, which is calm and usually normal, no noise happens, and then all of a sudden you have these cars with these mufflers that it feels like the person just added the loud muffler just to be annoying because they're trying to compensate for something, and they just roll through here, and it's the most annoying shit, especially when I'm recording, like, because I know the microphone picks these things up, and I'm like, dude, that's freaking obnoxious. So that's what course is. So rereading this piece right here, several factors can result in security misconfiguration, including improper incomplete data configuration, default configuration, publicly accessible cloud storage, the course, now that we know what that is, and error messages displayed with sensitive data. Intruders can take advantage of these things to perform detailed reconnaissance and get unauthorized access to the system. Security misconfigurations are usually detected by vulnerability scanners or auditing tools, and thus can be curtailed at the initial level. API documentation, a list of endpoints, error logs must not be publicly accessible to ensure safety against security misconfigurations. Typically, companies deploy security controls like web application firewalls, which are not configured to block undesired requests and attacks. Okay. And the impact would be that these types of misconfigurations can give intruders complete knowledge of the components of the API. First, we can bypass security mechanisms, then stack, trace, or get other detailed errors, and that can provide the malicious actor access to confidential data and essential details, further aiding the intruder in profiling the system and gaining entry. So practical. If we use the same API tester, company MHT is facing serious server availability issues. Therefore, Bob developed an API for Rule 7 for pinging. And so this is the vulnerable ping endpoint. And it shares details regarding the server health and status. He designed the endpoint, however, he forgot to implement any error handling to avoid information leakage. So if we can make a GET request to our local host API Rule 7 using just a ping endpoint, we'll be able to get certain information about the server that we're accessing, including the location of the docs right here, including this specific one is the path to their controller, and the authentication vulnerability object, or the vulnerable authentication object, which is this specific endpoint, and then you have the string, so it shows the value, the size value of this thing, and then it obviously shows the vendor. So there's a lot of information that's being disclosed here. In the case of an unsuccessful call, the server sends a complete stack trace in response containing function names, controller and router information, file path, and we can use all this stuff for profiling and preparing for specific attacks. The solution is to just create an endpoint which is secure, that carries out error handling and only shares desired information. So if we make that same ping request, it doesn't say anything. It literally says success is not successful, so it's false. The network server, yada, 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 and please contact the administrator at this email address for further queries. So limit access to the administrative interfaces for authorized users and disable them for other users. Disable default usernames and passwords for public-facing devices. like routers, web application, and you know, routers come with default usernames and passwords, and a lot of times it's like admin. So the username and password is admin, password is admin. It's like, or admin password, something like that. You know, disable directory listing on set proper permissions for every file and folder. Remove unnecessary pieces of code snippets, error logs, and turn off debugging while the code is in production. So, is it an excellent approach to show error logs from the stack trace to general visitors? That is not an excellent approach. What we're going to do is we're going to go to the secure version of API Rule 7 and see what we can get. And let's see. So if we go to Rule 7 and go to ping_s, and instead of doing a post request, we're going to do a get request. And if we run this, it says 500 internal server error. So it would be 500. And what is the error ID number in the response message? The error ID number in this case is 1401. And there we go. We were able to go through our security misconfiguration. So injection, this is kind of a fun one. So injection vulnerabilities, what is that? Injection attacks are probably among the oldest API web-based attacks and are still being carried out in real-world applications. Injection flaws occur when the input is not filtered and is directly processed by an API, thus enabling the attacker to perform actions without authorization. The injection may come from SQL, operating system commands, extensible markup language, so XML, or various other types of language, JSON, JavaScript, all those things. Frameworks offer functionality to protect against this through automatic sanitization. However, applications built in custom frameworks like PHP, are still susceptible to these types of attacks. So injection flaws may lead to information disclosure, data loss, denial of service, complete account takeover, and they can cause the intruder to access sensitive data or even create new functionality and perform remote code execution. So we're now going to go to Rule 8, user login. And we're making a post request in this case. And this is a very common JavaScript code that essentially says or 1 equals 1, which always ends up sending true. So 1 always equals 1. And you get an authorization key from an account as shown below. So when you submit or 1 equals 1, which would be the password in this case, so it could be the quote right here is ending the previous command that was sent in, which could just be blank or anything else when you get some kind of a response from an API. So when you do that, it ends that the previous block of text or string that came in here. And so it ends that one, and then you say or 1 equals 1, which always ends up being true. 1 always equals 1. So if it's blank or 1 equals 1, then let me in. That's basically what we're saying here. And so in this case, it is blank or 1 equals 1. And if either of those things are true, then we should get access to the system, and we do get access to the system, and we get an authentication key. But if we went to the login secure version of the API endpoint, it says success is false, incorrect username or password, and that's how it should be. So ensure to use a well-known library for client-side input validation. If the framework is not used, all client-provided data should be validated first and then filtered and sanitized, and necessary security rules to the web application firewall. Most of these things, most of the time, injection flaws can be mitigated at the network level, and make use of built-in filters like frameworks like Laravel, CodeIgniter to validate and filter data. So can injection attacks be carried out to extract data from the database? Yes, of course. Can injection attacks result in remote code execution? Yes, of course. So what is the HTTP response code if a user enters an invalid username or password? In this particular case, it should be a 5, what is it? What's the response code? Oh, it doesn't show us, so we have to actually do it. So let's go and use the secure endpoint here. So this is API, what is it? It's Rule 8, user login S. So that's what we're doing. And then we're going to send a post request here. and we'll delete this thing, and we'll delete this thing, and I mean, these shouldn't exist. So if I send it, it'll say 403 forbidden. That's what the code is. So 403 forbidden is the response of the API. All right, so let's move on to the next one, which is improper asset management. Improper asset management happens where you have two versions of an API. So for example, API 1 and API 2, and everything's been switched to version 2, but the previous version was not deleted. So somebody could easily guess that the older version doesn't have the updated or the latest security features because it's old, right? That's why they did the update. So plenty of obsolete features of it, the version 1 make it possible to find vulnerable scenarios which may lead to data leakage and server takeover via a shared database, because typically when you update things, you only update the security or certain parts of the system, and all of the data gets transferred over exactly the same. So it's essentially about not properly tracking the endpoints, and potential reasons could be incomplete documentation or absence of compliance within the lifecycle of software development, which we're going to get into in the next couple of rooms. And properly maintained up-to-date API inventory and documentation are more critical than hardware-based security controls for an organization. So this is a big deal. The older or the unpatched API versions can allow the people to get unauthorized access or even complete control of our system. And if we look at the vulnerable version of this, so, or the old version, right? So API Rule 9, version 1, user login. It can return more information like balance address something against a user. So if we do Alice with, I don't know if this is a bad password or if their actual password, but if we do this, it sends their information, and I guess we're supposed to actually get that information. That's why they blocked it out. If we do version 2 and try to send that same information, it only sends their username and their ID, which would be all we want. So mitigating this would be access to previously developed sensitive deprecated API calls must be blocked at the network level. APIs developed for research and development, quality assurance, or production must be segregated and hosted on separate servers. And the documentation of all API aspects, including authentication, redirects, errors, the course policy that we just learned, and rate limiting, they need to have documentation of all of those API aspects and adopt open standards to generate documentation automatically. So is it good practice to host all APIs on the same server? That would be no. Make an API call to version 1 with username Alice and that password. So we're going to do that. And what's the amount of balance and what is the country for Alice? So let's copy this password, and we're going to rule 9, version 1, user login, and we're going to make a post request. And it's Alice for the username, and the password is this thing. Wait, what? I thought I copied this password. There we go. And so we're going to send that information. There we go. $100 or 100 whatever. Well, it's USA, so $100. 100, and the next thing is USA. There we go. Easy money. Now finally, vulnerability 10, insufficient logging and monitoring. All right, as the name implies, when somebody tries to attack your system and when you try to track them, there isn't enough evidence because of there's not logging or monitoring being done, or if it's, it's bad logging and monitoring, whatever, that is a big vulnerability. So a lot of organizations focus only on infrastructure logging, like network events or server logging, but they don't do API logging and monitoring. And information like the visitor's IP address, endpoints accessed, input data, and along with timestamps allows us to identify threat attack patterns. And if logging mechanisms are not in place, it would be challenging to identify the attacker and their details. So the latest web frameworks can automatically log requests at different levels, like the error, the debug, and information levels. And these can be logged in a database or file that can be sent to a SIM like Splunk for detailed analysis. And Splunk will then send you notification if it notices certain types of patterns going in place, and then it says, hey, this looks fishy, check this out, right? So continue to use this thing, and we're going to go to rule 10 logging, and we're going to make a GET request in this particular case, and it gives us our information. So message, abnormal activity has been detected, the IP address is this, the browser is this, which is our user agent in this case, and then timestamp, and all of those things has been logged. So ensure that the SIM system, ensure the use of the SIM for log management, keep track of all denied accesses, failed authentication attempts, and input validation occurs, and format imported by the SIM, and enough detail to identify the intruder, and then handle logs as sensitive data, and ensure their integrity at rest and transit, and implement custom alerts to detect suspicious activities as well. Should the API logs be publicly accessible so that the attacker... No, no, it should not be publicly accessible. What's the HTTP response code in a successful logging of user information? And I'm going to say 200 because I think that's basically what the success response code is. Yeah. But let's just do it anyway. Why not? Let's actually do this thing. So we're going to make a GET request to rule 10. And logging is the API endpoint. And we're going to send that. And there we go. Hi, an abnormal activity has been detected by you on this thing, yada, yada, yada. So same exact thing, but I already know what a success response or what a response code for a successful request is, because that was a part of the HTTP basics room, right? And there we go, just like that. We finished our OWASP Top 10 Part 2 of the OWASP API Security room and module. If you found this information useful, I do invite you to go ahead and like and subscribe and turn on the notification bell and find all the good videos that we have on here. We're currently at 139 and I'm going to be adding 2 more, or actually I don't know, by the end of this weekend I'll probably end up adding 5 or 6 more to the publishing queue. So there will be a lot of stuff that you can go and click on search and just start searching through the content and find whatever you need. And the channel is on ethical hacking and cybersecurity. So there's a lot of stuff that you can get access to. And I'm probably gonna update this picture as well. This has been around since the very beginning of this and I like it, but I think it's time for an update. So yeah, that's pretty much it. It would be awesome to see you in the comment section. I do respond to all the comments that come in. And if you have any questions that are pretty juicy, I'll even create a video for you for your comment and question. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I will see you in the next video. Later.